Hey guys, so this is my interactive notebook for calc stuff. So if you're taking calc next year, you might want to make these sections or at least just watch this video. This first page I have is about the power rule. And this is where you have something to a power. You bring that power down and then you subtract 1 from it. So what I have are 3 post-its that are folded into thirds and then they fold out kind of like a little accordion. And I have step 1 and step 2. Okay, so this is really easy to make. So I've got the problem 4x squared, fold it out. I started by bringing that 2 down. That's where I get the 8 from. Then I subtract 1. So feel free to pause if you need to write that down. The next one is a little different because the exponent is on the bottom. You want to start by rewriting it and by moving that to the numerator and making it negative. Then I can do the power rule. There's my step 1 where I multiply it. And then I subtract 1, and that's my answer. Last one that I have is I have the cube root of x. Once again, I want to rewrite that so that it's an exponent, and then I can multiply it and subtract. Okay? So if you can multiply numbers and subtract, then you are good to go for the power rule. I have some other little tidbits here about derivatives and an example if you would like to have those. The next page I have for calc that you didn't see in class is this page, and I think I handed this out. If not, if you need any of this stuff, just stop by, let me know, or you can make it yourself. So in calc, there are just some things that you just need to memorize. You can't always work things out. So that power rule helps me find derivatives. These are just ones I just know, okay? So these are certain trig derivatives. The derivative of sine is cosine, derivative of cosine is negative sine. These are things that you just memorize. Underneath of that, these are more derivatives. These are more like your exponential logarithmic rules. So what's neat is that the derivative of e to the x actually is e to the x. So here's the problem. There's the derivative. Okay? Another section that I have is a section for the chain rule. With the chain rule, this is when you have a function inside of another function. So if you notice here, I've got 3x plus 5 inside of the square root of x. Here I have x squared inside of the sine function. And this one can kind of throw people off a little bit, but the inside function is actually 5x, and the outside function is e to the x. So with the chain rule, it's a function inside of another one. This is why we reviewed the composition of functions. What you want to do is you want to take the derivative of the outside part. That's why I just did f prime. The inside part stays the same. Then I multiply it by the derivative of the inside part. So here's my first example. You always want to start by rewriting things. Anytime you see a radical, so I rewrite it as 3x plus 5 to the 1/2. From there, I'm using the power rule. I'm bringing that 1/2 down, subtracting 1. I left g of x alone. Then I'm multiplying it by the inside part. Then kind of just comes in the algebra. I'm just rewriting it. These are the exact same thing. So I rewrote it by making that 1/2 a radical again and by moving it to the denominator. Okay? So the outside function is sine. The derivative of sine is cosine. Leave g of x alone. The derivative of x squared is 2x by the power rule. And then I'm just rewriting it. The last one that I have here is the derivative of e to the x is just e to the x. The inside function is 5, or 5x, so the derivative of that is 5, and rewrite it. Okay? This is one of those rules that the first time when I first started taking calc, like I just could not wrap my mind around it. These are really basic examples. Eventually, you'll start incorporating multiple rules together. I'm going to talk about some of those in just a sec, but this is just the basic foundation, and you'll learn all about this when you take calc, but I really think just being exposed to it now will help you out a lot. Here's the last page that I have for you. I just used 2 post-its, and I have these if you need them. I got these at the dollar store, and they're just nice and a little bit bigger. These are more derivative rules. There's product rule and quotient rule. Those are exactly what they sound like. If you have a product, if you're multiplying, you can take this can be written a couple of different ways. So the idea here is that you want to take You want to leave one piece alone and multiply it by the derivative of the other piece. Then you want to take turns. You want to let the other piece take the derivative and multiply it by the original. So it's like original, derivative, derivative, original. So here's an example. If I have 3x squared times cosine x, well, I'm going to leave this function alone and then multiply it by the derivative of cosine. And that's just something that you're going to have memorized. Trust me, it'll just happen. Then I'm going to take the derivative of 3x squared using that power rule and keep the second one. The only thing you can really do is just rewrite this. So I like to put my negatives out front, and that's all that's going on here. This last thing I'm going to talk about is the quotient rule. So that's where you're dividing. This one, the order does matter because you're subtracting this time, right? So subtraction isn't commutative. You want to take the derivative of the top times it by the bottom. Subtract derivative of the bottom times the top, all over the bottom squared. So let's say I have tangent x over x squared. Derivative of tangent x, just by memorization, you can peek at that trig sheet if you want, it's totally fine for now, is secant x squared. Then I'm going to multiply it by x squared. I'm going to take the derivative of the bottom, which using the power rule is 2x, keep the top, all over x squared squared. And you could obviously rewrite that as x to the fourth. Okay, so I hope that helps. You'll learn about all these things when you take calc, but I just want you to be a little bit ahead of the game, okay? Have a great summer.